Assalamualaikum and hi everyone. I'm Hazruddin Hafifi bin Asrul Hisham. Will explain to you about the summary for PHY568, electricity and magnetism. So we go to the first topic, which is vector. First of all, we have to understand the basic concept of unit vector, which is the vector A divided by magnitude of vector A. Based on the past equation, they normally ask about the distance between two vectors, which means we have to find the magnitude of the subtraction between two vectors. If the question asks about the position vector or distance vector, we just subtract those two vectors. For dot product, we just have to multiply two vectors as usual for each term, but for cross product, we have to do the determinant to solve the question. Next is vector transformation. Is the question asked to convert from Cartesian to cylindrical? Just use this formula. Take note that we have to know what each terms of coordinate system. Let's say for cylindrical, they have rho, phi and z. So just refer to the appendix at the back. Same goes to conversion from Cartesian to spherical. Normally, if question asks to convert from cylindrical to spherical, we will convert it to Cartesian first, but it's kind of complicated. So just use this formula and we can solve it in a second. This is very crucial for electricity and magnetism. This formula, we really have to understand and memorize it. If the question asks us about the surface, we really have to know which one formula that we have to use. First of all, determine the coordinate system. Then we determine which terms are involved. As example, if the question asks us to find the surface of cylindrical system, then we choose the formula based on the which axes are actually changing over the surface. If the question asks us to find the surface that the phi and rho axes are changing, so use the formula that have phi and rho. As simple as that. This part is very crucial and it is an application of the vector calculus that we have learned before. For the Coulomb law, first is we have to determine whether it's the line, surface or volume. After that, we have to substitute. Let's say if the question is about the surface and in Cartesian system, we have to determine whether it's dx or dy or dz based on no change axis. Then we solve as usual. Take note that for the line and surface, it has an infinite line or infinite surface. So we have to use other formula. Also, it has a unit vector that we have to solve. For electrical potential, almost same as Coulomb law, but the difference is not involve any vector unit. For current density, it is quite simple since the formula that we have to memorize is only J equal to dl over ds and J equal to rho v. Last but not least, for magnetism. For Biot-Savart law, it's very similar to Coulomb law, but it's involve current and also have the unit vector that we have to cancel out. As conclusion, we have learned about four Maxwell equations. First of all, Gauss law of electricity. Electric field divergence is proportional to electric charge density. Secondly is Gauss law of magnetism. Referring to magnetic field, divergence is zero, meaning that there is no magnetic charge monopole in nature. Number 3 is Faraday law. Rate of magnetic field over time is induced electric field circulation. And last but not least, Ampere law. Referring to magnetic field in closed loop is proportional to electric current passing through the loop, including the rate of electric field.